Okay, so to solve this polynomial equation, well, it's going to require a lot of work. This is not that easy of a problem. And if you don't know this one specific thing, you're not going to be able to solve this equation. All right, so let's go and take a look at the problem. We have 4x cubed minus 13x squared plus 11x minus 2 is equal to 0. That is the problem. Feel free to use a calculator, but if you can figure this out and solve for x, well, that would be super impressive. Matter of fact, if you have the answer, put that into the comment section. I'll show you the correct answer in just 1 second, and of course, I'll walk through all the work and steps that are necessary in order to solve a problem like this in algebra. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, well, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. All right, now I'm going to be covering a lot of material in this video. I'm just going to basically be kind of summarizing a lot of different concepts that you absolutely need to understand in order to be able to handle solving higher order polynomial equations. So for example, if you were taking maybe a first year algebra course, you should be able to solve an equation just up to here. So matter of fact, we'll just take this x cubed out for a second. So this right here is a quadratic equation. So how to solve quadratic equations is a big part of what you learn in Algebra 1, first year algebra. But as soon as we kind of throw in another term here with a cube, all right, an x cubed situation, well, this is a whole different ball game. Okay, it really kind of ups what you need to know. And of course, you need to know this. As a matter of fact, you need to know much more than what this one specific thing is. So you may not have seen this level of math yet. This is typically stuff that you will learn in Algebra 2, College Algebra, or Pre-Calculus. So if you haven't seen this, well, this is what you have to look forward to. Okay, so let's go ahead and take a look at the answer. So the answer to this equation is the following. X is equal to 1/4, 1, and 2. All right, now if you got this right, that is super impressive. Matter of fact, I have to give you a happy face, an A++, a 200%. Matter of fact, I would just say if you were in my Algebra 2 class, I would say just take the rest of the year off. I don't know how you got so smart in algebra. Maybe you're watching that guy on YouTube. But anyways, this is very, very good work if you were able to figure this thing out. Now, one quick thing about a calculator. A calculator could help you out. Matter of fact, using calculators at this level of math is really important. And if you have not invested in a graphing calculator, you know, if you really want to learn, matter of fact, I can really spell graphing correct here, graphing calculator, you definitely need to think about investing in one. So I'm talking about calculators like TI-83, TI-84. There's other types of graphing calculators. Usually they're going to cost you at least $100 or maybe a little bit more. So these calculators are super powerful. And one of the things that you can do here is to graph this polynomial function, and the graph will give you a lot of clues on how to find the solutions. But you're not going to always be able to use your graphing calculator, but you need to know the specific algebraic techniques, and that's what we're going to be talking about. And I'm going to quickly go through this, and this is not going to be all that quick of a video because we have a lot to cover. So if you don't understand anything, you know, what I'm getting into, because I am going to be going kind of quick, we're talking about multiple different sections and chapters of algebra concepts that you should master here. So if you need help with any of this stuff, check out my Algebra 2 and or pre-calculus courses. You can find links to those in the description of this video if you need help beyond this video. All right, so first things first, let's take a look at this equation from a kind of big picture standpoint. All right, so we're dealing with a polynomial equation, right? This is a polynomial, and why it's a polynomial, again, this is something that you should know, but it is a polynomial, and it is a third degree polynomial equation. So we want to kind of consider this thing right here, which is the fundamental theorem of algebra, and more or less the fundamental theorem of algebra. It's a pretty fancy theorem, but it's an extremely important theorem, and it says, hey, if you have a polynomial equation, the highest degree, or the degree of that polynomial, okay, is how many solutions you're going to have. So this polynomial is going to have 3 solutions. Now, what type of solutions? Well, it can have real number solutions and it can have imaginary or complex number solutions. We just don't know, okay? But it will have three solutions. Now, let's talk about real number solutions. Okay, now again, these are things that hopefully you know. So the set of real numbers is what? Well, it's all these numbers on the number line. So it's like 0, 1, 2, -1, -2. So these are, of course, the integers. And then in between the integers, we have fractions, we have rational numbers, irrational numbers, etc., etc. Okay, so again, this is what real numbers are, and I want you to remember rational numbers. Rational numbers. Remember what numbers are? These are numbers that you can express as a fraction. So for example, 2, you can express as a fraction. Matter of fact, let me go ahead and just fix that definition. Rational numbers are numbers that you can express as a fraction of using integers. Okay, so for example, 1/2 is a number that we can express as a fraction using integers because the numerator and denominator is an integer. -1/2 is again a rational number. 7 is a rational number, etc., etc. Okay, all right. So keep that in mind. All right, so these are this is kind of the big picture in terms of facing an equation like this. We're like, all right, we have a third degree polynomial equation. There's absolutely going to be three solutions. I have no idea if they're going to be a real number and or imaginary or some sort of combination. So we need a way to kind of, to get started here. Now, again, if you had a graphing calculator, that would provide a tremendous, clue on where some solutions could be. Now, you could even graph this by hand, but that's a lot of work. So we need some other tools, and that's what we're going to get into here in a second. Okay, so I'm going to show you something that you absolutely need to understand at this level of math. And before I show you this, we want to make sure that our polynomial is written in standard form, highest to lowest power, and it's set equal to 0. Okay, so of course we already have that situation. Now I want you to pay attention to the leading coefficient. Okay, so the number in front of the leading term is 4. That's going to be our Q. And you're going to be like, what is Q stand for? Well, I'm going to show you here in a second, but just know that this is going to be our Q. And then this little -2, our number is going to be our P. Okay, so we're going to be using these two things to give us a clue on this possible solutions for this equation. All right, so again, we have to be in standard form, and our leading coefficient is Q, and our last number here is going to be P. Okay, so what am I, doing here? Well, I'm talking about an extremely important thing, and this is what I was alluding to in the title of this video. You need to understand this one thing in order to solve this equation, and this is called the rational root theorem. Now, there are even other theorems. This is a big, huge topic in advanced math, how to solve polynomial equations. There's other theorems I could kind of get into that will give you more like kind of additional clues on where the possible solutions and roots lie. But this one right here, you absolutely must know. Okay, so the rational root theorem. Okay, so let's just take a look at the name before I even tell you how to, how it works. What is this name right here? Rational root. Well, we're talking about rational solutions. So a root is an answer. It's a solution to our polynomial equation. So we could even kind of name this rational solutions theorem. So what is rational again? Well, we're talking about rational real numbers. We're talking about numbers that can be expressed as a fraction of integers, things like 1/2 or 1/5 or 2/7 or 8, 9, 1, etc., etc. Okay, so the rational root theorem is basically the following. Okay, now we're going to look at how to actually use the theorem, but let's just kind of understand its application or what it represents. So as I indicated, this polynomial, okay, this polynomial equation definitely has three solutions. Now, you could have some real number solutions. Now, if you do have some real number solutions, you can have irrational numbers, okay, things like the square root of 3, things like that, or you could have rational numbers, which is actually represented by this big old Q, okay? So Q, which is the set of rational numbers. Now, if this polynomial equation does have rational numbers as solutions, it can be part of a list that we can create. Okay, so in other words, we can determine and find any possible rational roots that this polynomial may have in advance. Okay, and this is going to have tremendous advantage for us in order to solve this polynomial equation. Right? So again, we don't know if this polynomial equation has any rational roots, but if it does, it's going to be part of a list that we can build using this P and Q stuff. All right, so you have to understand the whole purpose of the rational root theorem before we actually start building it. So again, one more time, just to be extra redundant, we don't know if this polynomial equation does have rational roots, but if it does, it's going to be part of this list of possible solutions, and we could build using this P and Q. All right, so what is the P and Q business? Well, P is this number, this last number in this particular example, it's -2, and Q is our 4. All right, so the rational root theorem basically says this. We're going to take a look at all the factors of P, and we're going to divide it by all the factors of Q. And we're going to end up with one big list of possible rational roots. Okay, so we really kind of have to see this in practice for this to make sense. So let's going to take a look at that right now. Okay, so we have our P and Q. Now let's go and take a look at the factors of each of these things right now. Okay, so what are the factors of 4? Okay, well, it's 1 times 4, right, or factors, but +1 and -1 times +1. I'm sorry, we could have a +1. I'll just list this out for this first example because there's a lot of work here. So 1 times 4, okay, is of course 4, but so is -1 times -4, right? That is a +4. So factors of 4, okay, is +(-1) and +(-4). But we also have 2 times 2, or -2 times -2. So anytime you list out these factors with the rational root theorem, it's always going to be positive and negative, right? So just think of the actual factors. Look at the number like, okay, 1 and 4 and 2 times 2. So it's always positive and negative. So the factors of this number, Q, is positive -1, positive -2, positive -4. Okay, so now let's go ahead and list out the factors of -2. Again, you're just going to just get in the habit of listing the positive and negatives for each of these. So it's going to be 1 times 2, or positive -1, positive -2. Okay, so these are our factors of P and Q. And remember, the rational root theorem states that we need to divide these. So this can be a little bit confusing if you've never seen this before. Got to be very careful here. So now let's divide these two factors. Okay, so P divided by Q, we're going to divide all the factors of P by all the factors of Q. All right, so positive -1, and then you're going to put a comma just like this, positive -2 divided by positive -1, positive -2, positive -4. Okay, so now we're going to have to look at each one of these and actually kind of figure out the actual solutions. We're going to have to start doing some division here. And you're probably saying, hey, Mr. YouTube Math Man, this is a lot of work. Yes, it is a lot of work. As a matter of fact, this is actually a pretty easy problem to do when it comes to the rational root theorem. So let's go ahead and build our final list. All right, so first things, we have to get all our factors of P, all our factors of Q, and now we have to start kind of building out all the possibilities here. So let's start with 1, okay? So we're going to take this 1 and we're going to divide it into this and this, okay? Then once we're done with that, we'll move on to 2, and then we'll move on to 4, right? Because we're doing division here. So what are all the possibilities when we divide by positive -1? So just go 1 divided by 1, well, that's going to be a positive -1. 2 divided by 1, well, that's going to give me 2 divided by 1, of course, is 2. Okay, so we're done with 1. All right, so now we're going to scoot over and take a look at 2. Okay, so 2 divided by 1 is what? That's 1/2, right? Sorry, 1 divided by 2, excuse me. 1 divided by 2 is 1/2, and then 2 divided by 2 is 1. We already have it in our list. Okay, so we don't have to write that again. So now that we're done with that, let's move on to 4. Okay, so 1 divided by 4 is 1/4. 2 divided by 4 is 1/2. Okay, so 1/2 we already have in our list, so we don't have to write it. Okay, so we've done every single combination of P divided by Q. Again, P and Q are the factors of these numbers. And what are we looking at here? Well, if our polynomial equation has rational roots, they will be amongst these numbers right here. Now, it's very well possible that none of these numbers are solutions in our polynomial equation. But if we do, or if we're lucky enough to have a rational solution in this polynomial equation, it's going to be one of these numbers. It's either going to be a positive 1, negative 1, positive 2, negative 2, positive 1 half, negative 1 half, and positive 1/4 and negative 1/4. Okay, so now that we have this possible list of rational numbers, what we want to do is start testing these numbers to see if any of these are solutions. Because if we can find solutions to at least even one, well, this is going to really unlock how to solve the rest of this equation. All right, so let's go and take the next step, which of course is having you quickly subscribe to my YouTube channel. You might be thinking to yourself, boy, Mr. YouTube Math Man, it's a lot of work to put together a YouTube video like this. Well, to me, it's not really work, okay? I love what I do, which of course is teaching math, but at this level of math, or any level of math, there's a lot of information. And a lot of people get frustrated in math because they're like, I'm bad. Well, you know what? It's one or two things are happening. Either they haven't put in, they're bad at math. That's what I meant to say. They haven't put in the work. You know, learning math, especially at this level of math and beyond, requires a lot of work. Okay, it requires effort, right? You might be thinking to yourself, well, I'm not smart enough. That's not the case at all. But you do have to ask yourself, are you working hard enough? And if you are working hard enough, well, then the second piece of the puzzle that you need is great math instruction. There's no way you can just do a quick review. A lot of people get deceived that they're learning math. Like, okay, I quickly understand the rational root theorem. Well, there's a lot of little moving parts and details that if you don't understand, it's going to get confusing. And the way I like to teach math is to break things down step by step by step. So if you're frustrated with math, well, then check out my full main math courses. You can find links to those in the description of this video. And at this level of math, again, you want to check out like my Algebra 2 and or pre-calculus course. All right, so let's get back to this problem because we have a lot more work to do. And here is our list of possible rational solutions. Now, the next part of this problem is a pretty fun part. So what we're going to do is check these solutions to see if any of these are actual answers. Now, when we talk about the rational root theorem, right? So a root, another word for this is zeros. It's pretty much all synonymous with solutions. We can even throw in x-intercepts as well. But a root, a zero, is in fact a solution to like a polynomial equation. Okay, so how can we check these numbers to see if in fact they are solutions? Well, what you could do is let's take for example, positive 1. Let's check this. Well, you could plug in 1 for x, right? So we would go like this, and we just do all this number crunching right here to see if we did all of this, if it turns out to be 0 and 0 is equal to 0, then 1 is in fact a solution. But this is not the way you're expected to kind of check these solutions. You could check them this way, but this is the long way. There is a much better way, and it brings me to another thing that you need to know at this level of math, and that's called polynomial division, specifically synthetic division. It is a shortcut way to check to see if in fact you have the correct roots. Now, that's another big deal. There is the remainder theorem. This is a big topic in math. So again, check out those courses that I referenced if you are confused about this. But let's go ahead and take a look at how we can check these solutions using something called synthetic division. It's super cool. And what we're going to do is set up a thing that looks like this. All right, so you got like an L type of bracket. And then these numbers, 4, negative 13, 11, negative 2, are the coefficients of our polynomial. And notice we have our cube, our 4 right here first, and this is in standard form. Negative 13, that's in front of our x. 11, that's in front of, I'm sorry, negative 13 is in front of our x squared. 11 is in front of our x, and then negative 2 is the number. Now, if we were missing any terms here, you would have to put in a 0. Again, I'm trying to explain something that really requires like a full lesson. But I think most of you kind of get that main idea. So we're looking at all the coefficients of this polynomial in standard form, so highest to lowest power. Okay, so here we go. So we have 4, negative 13, 11, negative 2, and then we're going to put a little line down here because we're going to specifically be looking at this right here, which is going to be the remainder. All right, so this is an awesome little technique. Again, we're going to be doing synthetic division. All right, now what's the whole point here? Well, we're going to check these numbers to see if any of these are in fact solutions to our polynomial equation. So we're just going to start with one and we'll work our way through the list. I'm not going to do all of these, but I am going to do a few so you can get the main idea. All right, so let's go ahead and start with positive 1. All right, so I'll start with positive 1. So I'm going to put a 1 just like this, and this is how this technique works. Okay, so your first number, okay, in this case it's 4, you drop down. Now I already did the work here, but I'm going to explain it. So you're going to drop down this 4, and then you're going to take this number, 1, and you're going to take 1 times 4. So what's 1 times 4? That is 4. You're going to put your answer in the next column. All right, now you're going to add down. Negative 13 plus 4 is what? Negative 9. Now you're going to multiply again. 1 times negative 9 is what? That's negative 9. You're going to put the answer in the next column. Then you're going to add down. 11 plus negative 9 is a positive 2. Okay, so then we're going to do the same thing again. So 1 times 2 is what? That's 2. Put it in the next column. And negative 2 plus 2 is what? It is 0. Okay, and this right here is what we are hoping to get. So if you have 0 as the remainder, or if you get a 0 as your last number, that indicates that this number here is in fact a solution. Okay, so this is a much easier way to check solutions than just plugging in that number. Both are equivalent, but you got to understand synthetic division. All right, so hopefully you understand what I did. We'll take a look at another couple problems, but here is something even cooler. Oh, no, let's say cooler, just as cool or interesting about synthetic division. All right, now here, remember, 4 was the coefficient in front of our x cubed, and then negative 13 was our coefficient in front of x squared, and then this was in front of our x, and this was our number. All right, our answer now, our answers, these here, okay, what happens is you go down a power. So this 4, if I wanted to kind of rebuild this polynomial, instead of x cubed, this would become x squared. Instead of x squared, this would become x, and then this x becomes a number. So this right here, 4x squared minus 9x plus 2, I know it's kind of hard to see that because I kind of wrote that. We can figure out the rest of the solutions because this is a quadratic equation. So we know that x is equal to 1 is a solution because we've got a 0 right here. Now here I can go through and figure out the rest of the solutions by solving this quadratic equation, or I can continue on using synthetic division using these coefficients right here. Okay, so you got some options, or you can use these coefficients. Now technically what you're supposed to do is take this 1 and then check for double roots. Somebody will be like, hey, Mr. YouTube Math Man, don't forget to say about double roots. Yes, again, you would take this 1 and you could check again. All right, so this is a big topic. Again, I'm just kind of doing an overview of this. I know there's a lot of information. You're like, boy, my brain hurts. So let's go to continue on. So here is our other remaining polynomial. Okay, so in fact, because x equals to 1 is a solution, we can even write that as a linear factor, x minus 1, this is equal to 0, and this times this, because x is equal to 1 is an answer. So now I could just figure this out using the quadratic formula or factoring or whatever the case is, and I would have my other x answers, okay, my other solutions. Okay, but let's go and continue on and practice synthetic division. So as I indicated, you can continue to check for rational roots by just using these numbers. We don't have to use all the numbers in the original polynomial, so we can check with 4, negative 9, and 2. Again, these aren't standard form, so let's go ahead and practice. So we got 4, negative 9, and 2. And so what's going to happen is this. We checked positive 1, and then you're going to check negative 1. You would see that that's not a solution. And now we come across to positive 2. So what's going to happen when we come across positive 2? Well, we're going to do this again. So 4, we're going to drop that 4 down. 2 times 4 is what? 8. Add down, and we're going to put that answer in this column. Negative 1 plus 8 is what? Or no, negative 9 plus 8, excuse me, is negative 1. And now we have 2 times negative 1 is what? Put that answer over here, negative 2. 2 plus negative 2 is 0, okay? Meaning that x is equal to 2 is a solution. So if this was x squared, remember this is coming from this quadratic trinomial that we had, 4x squared minus 9x plus 2. Well, we're just going to go down 1. So this is 4x, this is x, this is a number. So now we can just solve the equation 4x minus 1 equal to 0. And you can see when I do all this math, I get x is equal to positive 1/4. Now, positive x is equal to positive 1/4 is a rational number, but look, it's also in our list. So all this makes sense. And of course, you can plug in these rational numbers and test them in the original polynomial. There's a lot of different options that you have. Okay, so now what does this all mean? Well, it means that these are the solutions, and we're pretty lucky to have all rational solutions for this particular polynomial equation. Certainly, it's not going to always be the case that you have all rational, zeros or roots. So here is the main idea. Okay, when you're facing a polynomial equation, a third degree or above, okay, you're going to need some other big tools to solve these equations, right? So what are they? Well, one, if you have the graph, that is awesome. Okay, that will give you some clues. And if you want to know why, you got to check out my full instruction. But graphically, we can kind of locate where the roots are going to be. Having a graph is tremendously powerful and useful. But beyond that, we have the rational root theorem. But then you have other things called like Descartes' rule of signs, et cetera, et cetera. So you have a lot of different things that can help you out. But solving these equations are not so easy. So it's a big jump up from just quadratic equations to a third degree. It's a whole nother realm. Also, you can write this entire polynomial. You can factor it into what we call linear factors. So our answers were 1, 2, and negative 1/4, right? So let me just make sure that was a positive 1/4. Matter of fact, I have to fix this right here. So this is going to be negative. I kind of noticed that. All right, so we have x minus 1 times x minus 2 times x minus 1/4 is equal to 0. So these would be the factors of this. So if you wanted to factor this, you can try to factor it by finding these rational roots. Okay, so a big topic, and just imagine this is just an overview of this one problem. In terms of level of difficulty, this is not all that difficult of a problem because these P's and Q's, these lists right this list right here, there are problems where, what do we have here? 1, 2, 3, 4, different positive and negative number options. You can easily run into problems where you have like 10, 15 different possible rational roots. That's where you definitely need to kind of use those other tools that we talked about, like graphing, et cetera, et cetera. So a big topic, lots to cover. And if you don't understand everything, that is understandable. So just, use this feedback or use this video as feedback, right? But hopefully this, kind of helps you clear up some of these things that, again, if you're at this level of math that you need to know. So don't feel bad if you're like, boy, this is like, a lot of work. Yes, indeed it is, but you can definitely do this. And hopefully this little video helped you out. And if that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.